Okay, so this question is from our textbook, and it is question 2A. So just want to kind of walk through this to make sure everyone's got it. So by using mathematical induction, we need to prove the following statement's true. In this case, it's this one. So we have to start with the base case. Now, I don't have a magical number. They didn't give me a domain. So I'm going to assume that the domain is positive integers, but because that's kind of what it looks like we're starting with, because we're starting at 1, it would make sense that we're on the positive integers. So let's prove the base case. And let's start with n equals 1. And let's try that. So 1 squared is in fact 1. And is this going to be equal to 1/3 times 1 times 1 plus 1 times 1 plus 1/2? Goodness, it doesn't look like it's going to work, but let's see. So 1/3, so this goes to 2/3 plus 3 or times 3/2. Well, the 3's cancel, the 2's cancel, it turns to 1. So in fact, my base case works. All right, once we've accomplished the base case, it is time to make our assumption. We're going to assume it is true for n equals k. So just writing that out, I'd have 1 squared plus 2 squared plus blah, 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 plus k squared is the same as 1/3 times k plus 1 times k plus 1/2. So I've got my assumption. Now I've got to go to my inductive step. And for that, we're going to prove that it works for k plus 1. All right? So if I did that, I would end up with 1 plus 2, all of these are squared, plus blah, 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 plus k squared plus k plus 1 squared. And we're assuming that that is true for, or sorry, we're saying that it's got to be true for k plus 1 times k plus 1 plus 1 times k plus 1 plus 1/2. All right, just for grins, I'm going to go ahead and simplify just some of my brackets here because I'm not sure if I'm going to need it, but it seems to me that I probably will. So if I just write this as just combining my brackets, I'd get k plus 3/2. All right, I'm just going to leave it like that for now because likely that's what it's going to come down to. Right, so now we have to recognize that this is the front half of that, which means that I can rewrite this as 1/3 k times k plus 1 times k plus 1/2 plus k plus 1 squared. So that's going to be my left-hand side, and that's where I'm going to try to do all my work on. Okay, well, looking at this, looking for some common factors, I see one right away. So I've got a common factor here of k plus 1, because k plus 1 squared is k plus 1 times k plus 1, so I'm going to go ahead and factor k plus 1 out of this. So if I do that, I would end up with k plus 1 times the quantity, 1/3 k times k plus 1/2 plus k plus 1. Right. Okay. Let me think here. Well, if I was to multiply everything on the inside by 3, I'd get rid of that fraction. Yeah, so if I get rid of that fraction, I'd end up with k plus 1 times k plus 1/2 plus 3 k plus 1s. Okay. Is this simplifying at all? I feel like we're making progress here. I've got k plus 1 because k plus 1/2. We're looking good there. All of that's great. So let us multiply some things through. Yeah, let's see what happens if I multiply some things through. If I were to multiply, get 3k plus 3, I would get k squared plus 1/2 k. Okay. I am going to go ahead, I'm going to combine these, but before I do, so long as I do it to everything, I hate fractions. So let's get rid of some fractions by multiplying by 2. So I'd end up with 2k squared plus k plus 6k plus 6. So I get, again, working on this inner bracket, we're still multiplying by k plus 1. I'd have 2k squared plus 7k plus 6 times k plus 1. Now I'm going to factor that because I'm feeling good. I've got a k plus 1. I'm feeling like this might actually help me out. So let's see what happens. 6k plus, say 6, wow, 2k squared plus 7k plus 6. If I use splitting the middle term, I'm looking for things that add together to equal 7 but multiply to equal 12. That would give me 2k squared plus 4k plus 3k plus 6. And when I factor that, I would end up with 2k times k plus 2 plus 3 times k plus 2. So that factors in the middle to 2k plus 3 times k plus 2. So now with what I've got k plus 1. I've got k plus 2. Now I just need to make this look the same. And if I multiply, oh yeah, that's the same as k plus 3 over 2. Okay, feeling somewhat good about this. So I've got k plus 1 times k plus 2 times k plus 3 over 2. Well, right here, That's not looking the same, but I'm close. So, just checking where I was at. Got to there, got to there. Got 3/2. Where did my 1/3 go? Come on, Stoltz. Find the 1/3. 1/3, 1/3, 1/3. To there. Huh. Huh, huh, huh. Where did my 1/3 go? Got all of that. I just don't have my 1/3. Oh, where, oh, where? There. Use that trick. Got rid of there. So I'm close, close, close. Right. Let me think. Da, 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 da. Oh, here's my 1/3. So when I divided, when I multiplied by 3, it's the same by dividing by 1/3. That needed to come out. I just didn't write it down. So this also comes to the front here. So I would have had 1/3 the entire time, because all I did to get this 3 was I divided by 1/3, but I divided that out, and I just forgot to write it down. So I get 1/3 that. Looking at my answers, these two things, in fact, are the same. So, because my base case is true, and when I assume that it works for n plus k, I'm able to show that it works for k plus 1. Therefore, this works for all values. Man, that was fun. I hope you found that useful.